This lecture is about two very fundamental concepts of thermal physics, temperature and Zeroth law of thermodynamics. Say two objects of temperature T1 and T2 are kept in a thermally insulated container. Let me draw the picture. This is system 1 or object 1. This is system 2 or object 2. Temperature of system 1 is T1 and temperature of system 2 is T2. We say T1 not equals to T2, and both the objects are kept in a thermally insulated container, that is, no energy can enter or leave this container. Now, if energy can be exchanged between two systems due to temperature difference, then the two systems are said to be in thermal contact. We assume system 1 and system 2 are in thermal contact, so energy transfer will occur between them. Now, if I put a thermal insulator between them, then they will not be in thermal contact and no energy transfer will occur. After some time, these two objects will be in same temperature, and this situation is called thermal equilibrium. Thermal equilibrium is a situation in which two systems would not exchange energy if they were placed in thermal contact. Now, say we have three objects A, B and C. A and B are not in thermal contact, and we want to determine whether A and B are in thermal equilibrium or not. C is our thermometer. C is placed in thermal contact with A until thermal equilibrium is reached. When thermal equilibrium is reached, thermometer's reading becomes constant. We record the reading. After that, C is removed from here and then it is placed in thermal contact with B until thermal equilibrium is reached. And again we record the reading. Now, if the two reading is same, that is, if the two temperature value is same, then A and B are in thermal equilibrium. If the two reading are not same, then they are not in thermal equilibrium. We can summarize these results in a statement that is known as Zeroth Law of thermodynamics or the law of equilibrium. If objects A and B are separately in thermal equilibrium with a third object C, then A and B are in thermal equilibrium with each other. This statement can be easily proved experimentally. It is very important as it enables us to define temperature. If two objects are in thermal equilibrium, then they are in same temperature. If we know one object's temperature, then we can tell the temperature of other object. In the later section of this course, we will relate temperature to the mechanical behavior of the molecules of the object or the system.